We are exploring the 2016 ROS program application problem number 4. The main purpose of this project is to explore a robot's path when it takes equidistant steps between two intersecting lines. The robot starts at the intersection point and tries to walk in such a way that it returns to the original point. We used trigonometric methods, induction, recursive sequences, and de Moivre's theorem in our methodology. We also used tools like GeoGebra for graph construction. First, we solved the original problem to determine the relationship between the angle and the number of steps. Then, we extend the original problem to cases starting from non-original points and also three-line scenarios. We established multiple recursive relationships for the robot's step points and returning path. We took our results and multiple lemmas and compiled them into 6 theorems. We found the functional relationship between the angle and the number of steps. In fact, this function is injective. We called this Theorem 1. Theorem 2 highlights the locational relationship between step points, which depend on the angle theta. Theorems 3 and 4 establish the order of the step points on the returning path when the robot starts at point O and a point not O. Theorems 5 and 6 show the symmetry of three-line graphs and also shows that returning path step numbers are multiples of 4. Overall, we constructed multiple mathematical models to explore relevant questions. Coming back to the relationship between theta and m, one limitation we faced was that we discovered not every input of theta give an output of m. For example, for 18 degrees or 10 degrees, m does not exist when the robot leaves from the original point. Also, we found that some angles that weren't divisors of 180 could work when the robot leaves from a non-original point, like 63 degrees has 40 steps. In the future, we want to consider 4-line scenarios or perhaps 3 intersecting 3D planes.